Okay, let's talk about waveforms. Now, I'm not good at math, so we're not going to talk about math. We're just going to throw it out in a general way. This is a square wave. Now, I don't think square waves occur in nature. As far as I know, they're synthetically generated. And I used to play with square waves when I played with analog synthesizers. Here's a more realistic look at a square wave. As you'll see, there are a lot of little jaggies in there, and these are harmonics. And these little harmonics, or these higher frequency components, are actually necessary in order to sustain the waveform of a square wave. Now look at the corners of this square wave, this general diagram of a square wave. Look at the corners. They're sharp. They're high frequency components. Now what's the difference between a square wave and a sine wave? Well, a sine wave is one of the most important audio waveforms. Here's what a sine wave looks like. Now, are sine waves and square waves related in any way? Well, who cares? But let's ask this question. Can you turn a square wave into a sine wave? And the answer is, well, yeah, sort of. If you had a 100 cycle per second square wave, audio signal, 100 cycle per second square wave, and you ran it through a really steep EQ filter, and you chopped off everything, say, above 200 cycles per second, it would end up looking like this, which is pretty much a sine wave, or at least it's close enough.